The recording started now. So let's go to the Canvas website. And I know several of you have already been on there. Most of the stuff is already on the front page. This Canvas website, perhaps you may have seen this layout before, perhaps you may not have not. Most instructors just line up modules, and that's the way they do it. This is a little bit more involved. There's a ton of information on here. If you have not been on here yet, I would suggest you do, because it's going to take some navigating. Syllabus, the link on the front page on the left side is exactly the same. It lists everything that you need to know. Syllabus reads like a legal agreement, runs into 14, 15 pages long. It is an agreement. It is an agreement between the student and the instructor. It's the agreement between the student and the instructor about the classroom. The instructor is telling the student, this is what you can expect. This is what you can expect of the class. This is what you can expect of the instructor. Okay. And at the same time, the instructor is also telling the students, this is what is expected of the student while you're in the classroom and while you're going to. Okay. Oftentimes it happens, there are some rules that are not laid out correctly, or they are not laid out specifically. Students would come in the middle of the quarter saying, you cannot do this because you did not tell us at the beginning of the quarter, and it is not listed anywhere in the syllabus. And so for that reason, every single thing, it kind of like builds up, and then now it's like a Apple document that you just sign at the beginning. That this is 15 pages long. Who cares? I'm just going to sign it. But everything that you need to know is in the syllabus. Okay. Slides are already on there. Office hours, class notebook. Actually, you know what? Let's do office hours, then I'll come to the slides. Okay. Communication is very easy. I'm very accessible. My email is on there, hr@calpoly.edu. You can email me directly. You can email me through Canvas, send me a message, either ways. I'm not a millennial, but I still have my smartphone tied to my hip at all times. I am very prompt and quick at responding to my emails. Office hours, I'm always accessible. I'm always happy to see students in my office. Outside of these 3 hours, we're 9 to 12, Monday, Wednesday, Friday. If I'm in my office, just knock on the door and come on in, whether to ask a question about class or about anything else. Just want to have a quick chat, want to say hi, absolutely fine. Okay, stop by. Lab times are listed here. I'm happy to see students even during lab times. Okay. Lab times, my focus will be on the lab students, but there will be moments, or there will be few minutes here and there, but 5 minutes or 10 minutes where I might have some available time. Okay. So if a student stops by during a lab class and asks me a question, I will answer it. Okay. So if none of the other times work for you, but this time works for you, like 3 to 6 on a Wednesday, feel free to come by. I'm in the same building 20, which is across right there. It's across the road, across the street. Okay, it's the electrical engineering building in the shape of an E. Is the antique looking building that has been on campus ever since the campus was established. Okay. My office is also in the same building, room 117. It's in the middle of that E. And then room 126, where the lab classes are held, is on the far end near the Dexter Lawn entrance. Okay, some of you are also in my lab class, so that's where you would see me. Okay. Let's see. Mondays, the student lab meetings, it's not fixed yet. It's it's going to fluctuate. So as the weeks go along, sometimes might open up over here. So I might change this, open it up to office hours. And again, the office hours that are listed on here simply guarantee my availability in the office. But I'm also in my office at other times. Typically, I'm always in the building somewhere. So send me an email. Just make sure I'm in my office before coming over, and I'll be happy to meet you. I'm also available on Zoom. So if you need to see me on Zoom, send me an email. Saturday nights, Sunday, if I'm not doing anything, if I'm free, which typically nowadays I'm not doing anything except work. So, if you're working on a Saturday night, if you need any help, send me an email. If I'm free and available, I'll hop onto Zoom and answer a query quickly, efficiently. Okay. Really, truly, try it out sometime. All right, so that's office hours. Lecture slides are already on there. Again, it's all mentioned in my email, but I want to mention it again. You can download them, print them out, which who prints out anything, right? No one prints out anything anymore. You can have them on your tablet, on your laptop. So that's one way you can access the course material. Complex numbers practice sheet is something I wanted to point out. The reason on the discussion question to ask you about your calculators is so that everyone knows which calculators you are using, because you will need to use those to perform complex math, literally math with complex numbers. Okay, in electrical engineering, the letter I is reserved for electric current. So we use the letter J for the imaginary number in electrical engineering. So when you open up this complex number sheet, you will see some example problems where it lists J, lowercase j, represents the imaginary number I. Okay, as I is reserved for current, I still don't know why. So they just pick the next letter, J. Each and every student needs to be an expert at using their own calculator devices to perform this complex math, without which you will not be able to do the second half of this class. Okay, so you need to get started on this as early as possible. You go online, look up your device manuals, videos, internet tutorials, reach out to your peers who have the exact same device, right? You go through the discussion forum and learn how to use your own devices to perform complex math. As engineers in your own field, this is a tool that you need to have in your toolbox. Imaginary numbers is not exclusive to electrical engineering. You will encounter it in other avenues and other fields, right? In your own fields. So this is something that you need to practice. So that's lecture slides. Let's see. Use class notebook. Class notebook uses, or not uses, is based on Microsoft OneNote. How many of you use Microsoft OneNote? Some of you. Microsoft OneNote is a very powerful piece of software. It's free for everyone, not just for Cal Poly students or faculty and staff. It's a free software designed by Microsoft. It is a digital notebook. Okay, you can have multiple notebooks, you can have multiple sections inside a notebook, and you can have multiple pages inside each section. Okay, the feature I use is the class notebook feature. Okay, the class notebook feature is you sign up through Canvas. I write using it as a digital whiteboard at my end, and anything that I write here anyone know the sentence? No? Yeah. Yep. What is so special about this sentence? Absolutely. Every single letter of the alphabet is good for handwriting practice. A through Z. Okay. Handwriting is a lost art. So if you can't read my chicken scratch, oftentimes I would go very fast. Just just raise your hand and let me know, what is that word or what is that letter? So I used to have good handwriting, but somewhere along the way I lost it. The point being, the material is delivered via the class notebook. Okay, some of you have signed up. I would strongly recommend you sign up. Okay, it's not going to cost you anything. What I do is I use the digital whiteboard to write and annotate the slides right here in real time. This is shared over Zoom. It is also recorded. Okay, so in Zoom, the only thing that is being recorded is the shared screen. The shared screen is projected in the classroom. So anything I write on here, you can see in person. Students who are online can also see it online. And of course, they can hear my voice too. So class notebook material, you sign up, anything I write or annotate automatically shows up at your end in real time. So if somebody is logged in right now, they should be able to see my annotations in real time at their end. Okay, all of these slides should already be available to all students. That's the beauty of this class notebook. Okay. Taking it one step further, since we talked about how the material is sent, attendance. I do not take attendance. I do not mandate attendance. Okay, you are adults. I treat you as adults. You are in charge of your own education. You can attend class in person. You can attend class online. You can choose neither one of those options and choose to view the recorded lectures. I typically post the recorded lectures shortly after class, typically by the end of the day. So you can attend in person, attend online, view recorded lectures, or you can do neither of those three if you don't want to. As long as you submit all of the work that is asked of you, that's all I care about. Okay. What I care about is that student will learn. So the structure of the class is set up so that students have multiple avenues to learn, whatever works for you. If you're going to be absent one day, you don't have to tell me. You don't have to notify me unless it's a Monday and it's a quiz day. All right. Unless it's a Monday and a quiz day, we'll have weekly quizzes every Monday. I'll get to that in just a short while. But again, attendance wise, you don't have to attend class. Okay. You can come in class anytime you want. You can leave class anytime you want. It's not going to offend me. It's not going to bother me. If you need a place to nap, you can come here and nap at the end, right? The chairs are not that comfortable, but yeah, I have it on good authority that the sound of my droning voice is a powerful sedative. Okay, so if you need a place to nap, you can come and nap. You want to relax, come and relax. It's fine. It's not going to bother me as long as you're not causing any disruptions to the class. That's all. One morning you wake up late, you want to attend online, you don't have to notify me. Just jump onto Zoom and just, attend class that way. Sounds good, right? There are no midterms in my classes. Okay, yay. No midterms. It's those weekly quizzes. My sweet spot for the number of quizzes is 8. We have typically about 9 weeks, barring the first week of the quarter. And I typically try to target 8 quizzes every single Monday. You have a quiz. And by my estimate, it easily adds up to about 2 midterms or more. Okay, but 8 weekly quizzes kind of take the pressure off the students. And so students are more encouraged to learn rather than just being in the pressure of giving a test. Okay, that's my philosophy. Quizzes are also available to take online. The only thing is it's not an online quiz. It's like you can take the quiz online, but you'll have to have cameras on for proctoring purposes. There are some rules specific to taking the quiz online, but it is possible. So it always happens. I might see students in the first week of class, and I don't see them again at all until the day of the final exam. And it happens, and it's fine with me. As long as you're learning, that's all I care about. Okay, so that's with regards to the attendance and the quiz. Coming to the homework, I use Pearson's online system for my homework. And so that's accessed through here, Access Pearson. So all the homework assignments are already on there. And unfortunately, there is a purchase price to be paid for the access code. Every student does have to purchase this. Now, when I was a student and I went into a class and first I heard about purchasing a code, I would just think, hey, this professor's lazy. They don't want to teach us anything. They don't want to do any grading. But that's not the case here, I assure you. Okay, I've had the system in place for several years, and every single quarter, once the quarter ends, students have always given me feedback that yeah, we had to purchase this code, but it truly enhanced my learning of the material and the way the class was structured. Okay, it's not a way to get out of grading. I can easily get graders from the department, so it's not a grading thing. It's more to the benefit of the students. Okay, this course, more than any other course, requires a lot of learning. Okay, the learning that you're doing in this class, the material that you learn in this class is mandated by your departments. Your departments tell us what we need to teach you. Okay, so the syllabus, the material, everything is selected by your departments. So it's not just me randomly coming up and saying, hey, this is what I want you to study. It's your departments telling us to teach you. That's what it is. So what you are going to learn is basically snorkeling. 1 quarter, right? Each student is going to go scuba diving into the material. You are going to skim the surface. Okay. The E student learns this exact topic, or all these exact topics, but they are going to take 1 academic year to learn everything, whereas you will have to get it done in 1 quarter. Hence, snorkeling versus scuba diving. Okay, we are not going to go too deep into the material. We will skim the surface, so to speak. Also, we won't go too deep into the semiconductor physics of things. We won't go too deep into the physics of things. Everything that we do and learn has a basis, physical basis in real life, but we won't go into the physics of things. We will stay on this side, right? We will talk about electric current and the movement of electrons, but we're not going to look at how the electrons are moving or how it affects, the energy band gap, the energy band diagrams, semiconductor physics of things. Make sense? Hopefully. All right, so coming back to this homework, it's structured in a way that there are some assignments that are bunched up together. Again, the holiday at the beginning of the quarter doesn't help. Holiday in the middle of the quarter or the end of the quarter is ideal, right? You can have extra day to study and all of that. But at the beginning, just messes up things a lot. So the homework assignments at the beginning are based on your prereqs, which is what I stated in the email. KCL, KVL, power, energy, all of those you have already done in physics, right? But in my previous experiences, I found is students might have taken it 1 quarter or 2 quarters ago, sometimes more than a year ago. So there's a gap. And if you do not refresh your memories, it'll be very hard to get caught up in this class. You'll be like behind in this class from the first day of class. Because any circuit analysis technique that we learn will be based off of those techniques. KCL, KVL are used to generate equations for analysis techniques. So I give those homework assignments at the beginning to refresh students' memories. It shouldn't take long. I will go over KCL and KVL in class also. But again, the Monday holiday doesn't help. All of the homework assignments are bunched together as 40% of your overall grade. So it's not as if it's a massive, it's not as if it's a small 10% chunk. When you are spending money, I make sure that you get your money's worth. Okay. Each homework assignment has extra credit tutorials. There are tutorials in there. So students who wish to brush up on the fundamentals from the previous, previous topics or even the future topics, there are extra credit tutorials. There are video solutions in there. They are all optional and extra credit. Okay, so you do not have to do those. So it's multi-level. The course is structured as multi-level. So if you wish to do those, you will be awarded extra credit. Any extra credit that you earn is not lost. There is no maximum cap. It carries over from every homework assignment to the homework category to the overall grade. So every quarter, it ends up that several students will earn more than 100% overall in my classes. Okay, so last quarter, I had students who earned 101%, 105% overall grade. That's like an A++, which, there is no A+, but if there was, this would be an A++. And I have no problem awarding every student an A. If you earn it, you get it. Okay, I'm not going to have a cutoff like 10 students an A and everyone else is a B or a C. I'm not like that. If you work hard and you earn it, I have no problem assigning you an A. Okay, so homework is a massive chunk. It's 40%. It's also further split into 2 parts. Please read the Canvas page about it. Let me know if you have any questions. Okay. Also, every homework assignment has flexible due dates. There is a due date on there, but it's soft, meaning if you complete your homework within that due date, then you'll earn 100%. Well, assuming all of your work is correct. But for every day that you're late, you do not have to request an extension from me. Okay. The homework is always open. The only thing is there's a small penalty of 5% for every day that you are late. Okay. Every homework question has a maximum of 30 attempts. If you get it right on the first attempt, you earn 100%. Every attempt you take further will deduct 3%. These are settings that I have implemented in the homework. Okay. But the system is not transparent to me. So I can set points for every problem, but every problem has multiple subsections. So the subsections, the system automatically assigns the points and it automatically assigns the deductions or calculates the deductions. But typically it happens. Students end up overall earning more than 100% on almost every single homework. Okay. If you get stuck somewhere after 5 attempts or 10 attempts, just reach out to me. I'd be more than happy to guide you. Okay. And we will go over and we'll look at homework problems in class also, so that students know what and how to solve the problems. Yes. Just that one question. Yeah. But it's not an exact 3%. I've never managed to figure out how the system does it. It's something that their coders have done and set up in the system. And because some problems will have like 6 or 7 sub questions, and then system automatically just assigns some points to it, and then just deducts the points based off of that. But the point is, everything is set up so that it benefits the student. Okay. So it'll be easy to get a decent grade in my class. Conversely, if you don't do the homework, it'll be very hard to get a good grade in this class. Okay, so you have to keep up with the homework. You have to set aside now, whether you're out of here, whether you are here in this classroom out of your own interests or because of the department, doesn't really matter. You are here, you have to make the best of it. The system is in place so that you can learn and earn the maximum points that I've set. Okay. So again, everything is geared to the benefit of the students. Do your homework. Set aside 1 to 2 hours every day for this class. Okay, and you should do that for every class. You have to be disciplined. You set aside at least 1 hour. Okay, doesn't matter. Doesn't matter whether you're bored, whether you're tired. Set aside 1 hour. Be disciplined, and then in that 1 hour, complete as much as you can. 1 hour, you get frustrated, you get bored, leave it on the side. That's fine. But at least 1 hour every day. Otherwise, it'd be very hard to get caught up in this class. It'd be very easy to fall behind. Okay. So if you go on the website and you go into assignments, and at my end, it always, instructor end is very different than a student end. Okay. If I do student view, typically the student view would be arranged by date, right? Which is what you want. You want to know when the deadlines are. So all the deadlines and dates are already set on there. You should already have your Canvas calendar set up. Find new assignments. What happened? No, there we go. So this is show by date, not telling you which assignments are coming up, but at least show by type once. Try this at least once and see how all the assignments are structured. We have the discussion, surveys, and quizzes. They're all pulled together as one group, 40%. All the homework assignments are pulled together, 40%, and the final exam, 20%. So 40, 40, and 20. That's 40, that's 40, and then the final exam, 20%. Okay. Homework is further split into 30 and 10, which is basically the scanned uploads. Every homework that you do, typically a homework, you'll be actually doing some work, right? You'll be doing some work. You scan that work and you upload it. Doesn't have to be neat, doesn't have to be very clear. As long as it's legible and I can see that you did the work and that it's all outlined in there, you'll get full credit for that. That is not, points are awarded, but it's not graded on neatness. It is not graded on accuracy or anything else. As long as the work is done and submitted, you earn full points. Mastering homework uploads, basically you do the work and you upload it, you get the full 10%. There is no deduction whatsoever. Yes. No, just the problem number. That's it. Like 10.1, 5.5. That's it. So multiple choice, true or false. So I have it on the homework page. There's a one line which says if it's a multiple choice or true or false question, just write the problem number, say T/F or MC, and that's it. You don't have to write the question or anything. Don't waste your time on doing all of that. Okay, the primary 30% of the homework comes from the Mastering Engineering website, right? And the 10% is the homework upload. As long as the homework is uploaded, you'll get full credit. So that's 40, 40, and 20. And then there's instructor evaluations. Okay, these are optional, extra credit. It's a little bit of extra work, so I like to provide students extra credit. The extra credit is the amount of, wow, it's already 11:40. The extra credit is the amount of the response rate. So at the end of the quarter, you fill out these official anonymous evaluations, right? You filled it out last quarter. We received those evaluations at the beginning of this quarter, okay? And the only thing we see is basically the points and the comments. Obviously, there's no student name or identity collected. And so, I can make improvements to my course based on my previous quarter's evaluations, right? These are important to us. But that doesn't help you in real time. So what I have done is I implement these forms where it's the exact same questions. Okay, it's just an inner form. It's the exact same questions that you see in the official Cal Poly evaluations. Every week, there'll be a reminder on Canvas for you to submit it. Optional, submit it or don't, right? But if there's something that doesn't work for you, this is the space to do it. Anonymous, it doesn't collect any data, right? You send it to your buddy in New York and they could fill this out, but please don't. But I'm just saying it's an internet link. Anybody can fill this out, okay? As long as they have the link, they can submit it. So it's anonymous and it's in real time. You can write "he sucks" on there, but well, tell me why. Tell me what's not working for you so I can do a course correction in real time, right? So if something's not working for you, this is a space to let me know what is not working for you. As an incentive, at the end of the quarter, I will total the number of responses, which is about 40 students in the class, 9 weeks. The response rate divided from the total number of possible responses. Every student in the class will receive extra credit in that amount. So 2% for these weekly evaluations and 1% for the end of the quarter evaluations, for a total of 3%. Hypothetically, if I have a 300% response rate or 100% response rate, every student in the class will receive 3 points directly towards your final grade. So if you end up with an 87 in the class, you will be bumped up to a 90. So whether you participate and submit or not, every student will receive the extra credit. Okay. All right. Further questions? Oh, that took longer than I expected. This Monday is really putting a crimp in everything. Again, reach out to me if you have any questions regarding the syllabus. Especially read the assignments page. Okay. Especially please read the assignments page. All right, let's go to the class notebook. So again, as I was saying, the class notebook is something that every student I would strongly recommend you sign up for, because you will receive these annotations directly in real time. Okay, so let's some nice memes that I like to use. Let's go directly to KCL, because that's the homework that is due tonight. Kirchhoff's current law, right? Kirchhoff or Kirchhoff, which is the actual German pronunciation of that name, came up with 2 laws, right? One regarding current, one regarding voltage, both of which are based on the law of conservation of energy. Okay, law of conservation of energy. Simply stated, if you sum up the currents or if you summed up the voltages in an electrical circuit, they should sum up to 0. They should sum up to 0. Now, is power negative? Do you ever say that you have a -10 or a -10 watt charger? No, right? Power is never negative. Voltage is never negative. Current is never negative. But it is for us humans to be able to balance out our mathematical equations that we put a plus and a minus sign in front of these quantities. Okay. In real life, voltage, current, power, energy are never negative. We would either say power is being supplied or received, or current is flowing in one direction or the other direction, or voltage polarity plus and minus. But in real life, it's never positive or negative. Mathematically speaking, we put a plus or a minus sign in front of these quantities in order for us to balance out these equations. Otherwise, they would never balance out. They would never sum up to 0, which is where KCL and KVL come in, right? If you look at this point here, what is that point? What is it called? It's a junction. It's a dot. Electrically speaking, it's called a node. Okay, so it's a junction where 2 or more components meet. 2 or more components meet. Okay, it's a junction. But it's called, electrically speaking, it's called a node. These are all wires. Okay, this is a wire. A wire is a conductor. It conducts electricity, or it permits the flow of electrons. In circuit analysis, everything is theoretical. That's the name of the class, electric circuit theory. You're learning theory. It's theoretical analysis. Theoretical analysis means everything is ideal. Okay, everything is ideal. We don't take practical considerations into account. When we say it's ideal, means that a dot is the same as a dash, the same as a short line, and is the same as a long line. It's exactly the same. A real life example would be your extension cable, your power extension cable. If you have a 100-foot power extension cable and you plugged it into your power outlet, what would you expect at the other end? You'd expect it to work. You'd expect the voltage to arrive at 100 feet away, right? So, oh, by the way, side question, general knowledge question. What is the voltage rating of the power outlet in North America? General knowledge question. 120. Outside of North America, Europe, Asia, most places of the world is 230, 240 volts. I'll expand on that on Friday a little bit, but this is something that might appear in a final exam. Okay. Voltage of a North American power outlet is 120 volts. It will fluctuate between 110, it's never constant like that. It might fluctuate depending on the load and conditions during the day and the time, might go to like 110, 115, 120. But for all intents and purposes, we refer to it as 120. Okay, 120 volts. If you look at any charger or adapter that you own, it'll always have a specific rating. Your cell phone charger, if you turn it around and look at it, tiny letters, it'll state the voltage rating of the input and the voltage rating of the output. All of them. They're all converting AC to DC. Okay. Well, anyway, that's a separate discussion. So coming back to the example, you have a 100-foot long cable. If you plug into the wall and you measure the voltage at the other end, you would expect to be 120. It might drop to like 119 perhaps, but even that's probably not, not significant of a drop. The resistance of that 100-foot long cable is probably 1 or 2 ohms or less. Okay. A wire has some resistance. It has some inductance. It also has capacitance. So any wire like this one, for instance, the USB cable, the HDMI cable, they all have resistance. They all have inductance. They all have capacitance. The level of resistance or inductance or capacitance does not rise to the level of interference. Okay, so a 100-foot extension cable might have a resistance of 1 or 2 ohms, but it does not interfere with the functioning of that cable. The purpose of the cable is to transfer 120 volts from one end to 100 feet away. The resistance does not rise to the level of interference. Now, if you take an HDMI cable and you extend it to 100 feet, then it'll have resistance that will rise to the level of interference. The purpose of the HDMI cable is to transmit digital video signals, digital audio and video signals from one point to another point. But more than 6 feet or 9 feet long, that resistance or inductance will affect the performance of that cable. Okay. The point being, again, the same. When you're working with electrical circuits on paper or in theory, everything is ideal, meaning all of this is one single node. And all of this is one single node. And all of this is also one single node. Wires are ideal, especially when you're doing theoretical analysis. It doesn't matter how long that line is. Electrically speaking, it's the exact same node. No difference. Let's take a 10-second pause. Think over that concept. Let me know if you have any questions. Any questions? Sometimes this is a hard concept for students to grasp, especially when they're under pressure trying to, write a test or an exam. Within 10 minutes, you have to make a quick judgment about a problem. But always keep in mind a wire is coming from one end to another end or a component. You look at it as a single node. Okay. A node is a junction of two or more components. If it does not have anything in the middle, meaning there's no other component connected, it is all electrically speaking the exact same node. Okay, so that wire could be short, wire could be long, doesn't really matter. What else do we see here? We see that IA is coming into this junction. Let me call this junction as N1. It's coming from the left, or at least going towards the right. IC is coming into the junction from the left, from the right. Then IB is going down. If this was a vehicular traffic diagram and I showed this to anyone, what would they be able to conclude? Mathematically speaking, yes, to some. But qualitatively speaking, in general terms, I would say they are one-way streets. They are one-way streets, and IA and IC are converging on that junction, right? Electrical pathways are one-way streets. Current can only flow one way, cannot flow both ways. Not technically true. There are some electronic devices where we have holes and electrons moving in opposite directions, but overall effect of that current is always that it's moving one way. So it's always a one-way street. Here we can say IA and IC are converging in the junction or going into the junction, and IB is leaving the junction. So mathematically, I can write that IA and IC combine to give me IB. And that's it. That's KCL. The way I implement KCL and KVL might be different than what you are used to. If you, actually, let me back up. You have been studying KVL, KCL for far longer than you would study it in this class. So if you have a preferred method, you stick with it. You do not, I'm not going to force you to use my methods, okay? KCL is rather simple, that's fine. KVL is more involved. So students have a separate method that they have learned, from their high school, from community college, or from physics classes in college. If you have a preferred method, you stick with your method. Okay, you do not have to change your methods to learn something new, or in this case. Okay, I'm not going to force you to do that. The way I apply KCL is, right, my equation, I place all the currents that are entering the junction on the left side of the equation. All the currents that leave the junction are on the right side of the equation. And then this equals this. That's it. So if I was to call this N2 at the bottom, and I was to write my expression for KCL, how many currents entering? IE, IB, and ID. And nothing is leaving, it's zero. Physically not possible in real life. This is Die Hard 4. Anyone not seen that movie? I'm sure plenty of people might not have seen the movie. There's a scene in there where hijackers take over the traffic cams and turn all lights green. So all vehicles converge in the same traffic junction at the same time. Die Hard 4. Not really possible, right? So theoretically, yes, we can write it out. IE, IB, ID are all entering the junction. Physically not possible. Either one or two of these currents are flowing in the opposite direction. And so we put a minus sign in front of it. At this point, we don't know which one, but the equation still stands. You do not change the equation at all. You write the equation directly from the direction that you chose or is given to you. Okay, make sense? You do not change the signs in the equation itself. You write down the equation as it is. So if I was to solve this, I would get, what do I get? IA and IC be 6 plus of minus 2 is IB. And so IB is equal to 4 amps. Right? IB is equal to 4 amps. And then I can plug the same how about the relationship between IA and IE? IA and IE. They are equal, exactly. It's the same current, but they're moving in the opposite direction. So mathematically, if I wanted to write an expression, I would say IA plus IE is equal to 0, or actually the other way around. Currents entering the junction N3 is 0, and currents leaving the junction IA plus IE. And so IA is minus IE or IE is minus IA. Either ways, doesn't really matter. Both are same. And so IE be minus 6 amps. Right? So plus and minus is just for us to know to balance out the equations. All right, any questions? 56, 4 minutes left. All right, let's get to KVL. Okay, electrical loop. Electrical loop is a closed pathway. You start at one point in a circuit, you go around the circuit, and you come back to the exact same point. That constitutes an electrical loop. Again, a loop is a closed electrical pathway. Okay, closed electrical pathway that allows you to come back to the exact same point. You can have nested loops inside a loop. Okay, you can have nested loops inside a loop, which is what we see here. We have loop 1, we have loop 2, both of which are nested inside loop 3. Loop 3 is also a valid loop because you can start at any point and you can follow that pathway and you come back to that exact same point without going back on itself. That's more important, without going back on itself. So anytime electrons move through a circuit or flow through a circuit, encounters a component, encounters some resistance, it causes a drop in electric potential. The drop in electric potential is defined as a voltage drop. Voltage, well, let me go back. Current, technical definition of current is the rate of flow of charge. Charge, electrons flow through a circuit, energy is transferred, charge is transferred. The rate at which charge is transferred, or the rate at which charge flows in a circuit, is defined as electric current. That is one of the questions on the homework. And voltage is defined as same thing, rate of flow of energy. Okay, rate of flow of energy. But more accurately, not accurately, but another definition for voltage is that it is the difference in electric potential between any 2 points. Difference in electric potential between any 2 points. If I was to say that my hand is at plus 5 volts, let's say the surface of the table is 0 volts. My right hand is at plus 5 volts. The difference in electric potential between these 2 points is 5 volts. Left hand is also at 5 volts. What is the difference between these 2 points? 0. So it doesn't matter what my reference point is. Electric voltage is always measured with reference to a certain point, right? So both of these could be at 100 volts each, but the voltage between these 2 points would be 0 volts, because voltage is the electric potential difference between any 2 points. So if I wanted to, it's about a minute left. If I wanted to write, let's say, loop 1, what I do is I write out all the voltages in that loop. If you have to leave, you can leave. Okay, at 11 o'clock, that's fine. I mean 12 o'clock. This is going to take a couple of extra minutes. VA, VB, and VC equals to 0. I start at one end and I go clockwise. I write down or note the sign that I encounter first for each quantity. So this is minus VA plus VB and plus VC equals to 0. Similarly, if I was to write this for loop 3, I have 4 voltages, VA, VB, VD, and VE equal to 0. VA is negative, VB is positive, VD is negative, and VE is positive. And that's how I would write my KVL expression. Again, if you have a preferred way of writing KVL expressions, you stick with what you know. Okay, do not be forced, do not feel forced to actually use this method. All right, so we'll have to end class here today, and I'll see you all on Friday. If you have any questions, please reach out to me. I will post the lecture videos shortly after I go back to my office, so about 30 minutes or so.